Well, hi, everybody. It's Barb, and welcome to Funtastic Science again. Today, we're going to meet Kathy. Kathy helps our scientists at NOAA by putting data from all over the world on our website. And scientists can use that to study the weather and climate. Today, she wants to tell us about some of the different kinds of weather that you might see out there and experience every day. So are you ready to get started? Here's Kathy.
All right. Thanks, Barb. Let's see here. Okay, so I was going to talk about Boulder's wild weather. I am a weather enthusiast, which means I like looking and studying about weather a lot. When I was young, I used to read about things like volcanoes and hurricanes and be interested in them. And I also went hiking and camping a lot, so I needed to know about the weather, so I didn't get. And also, I like just looking at clouds and looking at rainbows and that kind of thing. I find when I go outside. So for all those reasons, I got into weather at a young age. Okay, so Boulder's wild weather. Here's some of the things that we're going to look at today: tornadoes and lightning, thunderstorms, and clouds. I've lived in New York before, Seattle, and we had interesting weather there. Boulder is probably the most interesting place lived, partly because of where it's located. We middle of the continent, so we can get cold air very far from the Arctic, and we can warm air from both oceans, the Gulf of Mexico and from the Pacific Ocean. And the main reason, though, is we have very mountain range to our west, and mountains really influence the weather a bit, and they make it much more changing than places like Seattle or New York, where I used to live. Okay, so I promise this will be the only slide with no pictures. I just wanted to say in order to talk about wild weather, we have to talk about what's normal weather. Normal weather is what we call climate. So in Boulder, we have something called a steppe climate, which you don't have to remember, but basically it means that it's sort of dry. It's halfway between a desert and a place like New York or Seattle. We get about 20 inches of precipitation a year. Precipitation is a combination of rain and melted snow. And we also get around 90 to 100 inches of snow a year. It tends to rain in the summer and spring, like it did yesterday, especially when we have thunderstorm season. It snows in the winter, though it tends to snow at the beginning of winter in November, and it tends to snow more at the end in March. And so we're very hot and cold. Our highest temperature record was 104 back in 1954. The lowest temperature was -33, so quite cold. The most snow we've ever had in a day was 20.1 inches in 1997. We almost had that much this year in the Thanksgiving snowstorm, if you remember that. The most rain in a day was about 9 inches during the Boulder flood, which is almost half of what you get in a normal year. And the most snow we had was this year in the last 110 years, and that is we had 152 inches, so quite a bit. Okay, so like I said, one of the more interesting bits of weather in Boulder is the winds. Boulder's really known for its winds. So you can see here's a picture of the wind having blown over a branch onto a car. And below this was a very big windstorm we had back in 1971, where the power lines blew over from the strong wind. So the highest wind speed recorded in Boulder since people have been here is 147 miles an hour, which is very fast, twice the speed of a car. We have about 40 days over 100 miles an hour in the last 50 years. So that means almost every year we get a day where we have winds over 100 miles an hour. So those are pretty strong winds. Some of the types of wind events we get tornadoes, dust devils, Chinooks, which is a special name for a wind, and Bora, which I'll talk about in a bit. And we also get winds with thunderstorms. Okay, we have so much wind, in fact, that even though it can be damaging, it's also very helpful. So the National Renewable Energy Lab near Rocky Flat, just south of Boulder, has wind turbines you can see here, and they use those to help research how to get the most energy out of wind for the wind farms that you see around the country. So we have enough wind that we can do that here easily. Okay, so where does wind energy come from? It's a bit of an aside, and it comes from the sun. So in a way, as does all energy for weather. Basically, all wind, rain, all snow, all the movement of weather comes from the sun. So you can think of wind energy as a bit like solar energy, in fact. Okay, so go back to one of the types of winds I said is a Chinook. Chinook winds are very strong west winds that come from the west. That is, they come from the mountains. They tend to be very warm winds. So when you have a very strong wind blowing over the Rocky Mountains here, like when the jet stream goes overhead, as it descends, it goes down towards Boulder, the air warms up. And it's kind of the opposite of when you take, say, a bicycle tire and open it up and you get the air comes out and it's cold. The air comes out because it's expanding. So when the air goes down, it's compressing and it warms up. And that can melt snow when you have snow. They call the Chinook winds snow eaters. And even if you don't have snow, it can warm up quite a bit. So it can go up 50 degrees in a day. And that's not too uncommon. And Chinooks are most of the strong westerly winds we get in the Boulder Front Range region. Another type of wind, which is pretty similar to a Chinook, is called a Bora. Boras come from the north usually. They're very cold. And when they come down from the north, if you look and you see them before they get here, you can see a lot of dust because they tend to kick up the dust as they go along the Front Range.
Oh, that's cool.
Yeah. And so they, the temperature changes and you feel quite cold after they go by. Okay, another type of wind is a tornado. Tornado is basically a spinning cloud that moves along the ground. It comes from the sky, usually from thunderstorms. Boulder is right next to the mountains, so we don't get too many tornadoes, but we do get some. We've had about 12 in the area since 1953. I was lucky enough to see one. I see this one in this picture. So you can see this is looking from the Boulder campus towards Baseline Reservoir, so a little bit to the east. And you can see the funnel cloud or the tornado going down here. This is probably after it ended a bit, so it didn't quite go all the way. But that did go over near Boulder Reservoir, and I think it took a roof off a barn there. Tornadoes are formed, the ingredients for tornadoes are you need warm air at the surface, you need wet air so you can get all the rain, you need strong winds somewhere, usually a jet stream nearby, way up high, and you need some kind of spinning in the air. And basically, when you have all those conditions, the spinning can be turned straight up and down so that you get the funnel that spins, and that is a tornado. Okay, so as you go east, you can get bigger tornadoes because you're further away from the mountains, so the wind can blow harder. And here's a fairly large tornado up northeast of Boulder and Windsor. So this was pretty big. I think it had a lot of hail associated with it. You can get, if a tornado doesn't go all the way to the ground, you get a funnel cloud. And so here you can see the funnel cloud and this is in Denver, and this is Coors Field here. So if you were at the game that day and you looked out towards the north, you would have been able to see this funnel cloud. And in fact, they had a bunch of funnel clouds that day. June tends to have the most in the Denver Boulder area for various reasons, but yeah, if you want to go see them, that's the time to see them. Okay, and finally, the last tornado is one that I tried to see and failed. This was in north of Boulder and Lyons, which it's a little bit unusual because usually, like I said, you don't get tornadoes right by the mountains. And in fact, this one went from east to west. Usually they go from west to east. So it went towards the mountains, which is kind of unusual. On the right is where my daughter and I drove to try to see the storm. We were south of it. And you can see it's pretty scary looking, very dark, and the clouds really go down to the ground. And we were very careful to stay far away from the tornado and the dangerous lightning and so forth. But We got as close as we could to see it. So it can be fun to look at these kind of events, but you do have to be careful. Okay. Next, we have dust devils and snow devils. So these are like tornadoes. Basically, you have a spinning cloud. In this case, they're not associated with thunderstorms. So you just tend to have the ground heated up by the sun. And then you might have cold air above, which helps the dust devils form. They can be very small, they could be like just a foot big, or they can be very big, like 1,000 feet high. And some of them get up to 60 miles an hour, so pretty strong. Though usually they're not quite so strong. So if you drive in some places, you do have to watch out for them. They take on the color of whatever is on the ground underneath them. So in this case, this is in the St. Louis Valley, and you can see all this sand and dust, and that's the color of them. If you had red soil, you might have a red dust devil. In the bottom picture, you have snow, and so the same thing that makes the dust devil makes a snow devil, and so it picks up the snow, and you see those a lot if you go out skiing or in the mountains in Colorado. Okay, wave clouds. So the atmosphere, like the ocean, is actually a fluid. You don't see it, but it is composed of molecules or parts that move. And so the wind can basically create waves in that fluid in the air, and you see them in clouds. So the waves will go up and down, just like in the ocean. So this is one wave cloud. This was over Denver. You can kind of see here and here and here these little bumps, these little waves that formed when the air was very windy that day high up. In fact, this is a special kind of wave cloud called a Kelvin-Helmholtz wave. And again, you can see here, it looks like waves in an ocean where they go over and break. And you can see they're separated by about the same amount. And so they're interesting. You don't see them a lot, but you do see them in Boulder, especially in winter. Okay, another type of wave cloud is called a lenticular cloud. So you get these sort of flat clouds, very smooth, not very tall. So this is this tall, and you have another one here and another one here. And sometimes you have air between them, so you actually see layers. And it's interesting, these clouds look like a little bit like what people think flying saucers look like. So interestingly, the very first publicly reported flying saucer was over Mount Rainier, Washington, where they get a lot of these kind of clouds. I think it was back in 1947. And people still say they see flying saucers even today. Okay, so more of these sort of wave clouds or lenticular clouds. They're very smooth and very pretty. They can be lit up by the sun during the day, or at sunset, they can change all these colors. And they do indicate it's probably windy somewhere. The wind doesn't always come down, but sometimes it does. Here's a special kind of lenticular cloud, wave cloud, over Rocky Mountain Park, where I went hiking with my son. It was very, very windy that day. And you can sort of see this is a very thin cloud. And if you really look at it, you can see sort of purple and maybe light green colors. It's kind of faint, but you can sort of see it. And that's because these clouds are very, very thin, and that makes them able to bend the light in such a way that they actually have colors. So sometimes you can see this in winter. If you look around the edges, you'll see pinks and purples and light greens. So it's kind of neat to see. Okay, and one last one, this is where we work, where at least some people study clouds. So it's good that you can look out and see these kind of wave clouds. Okay, the next thing I want to talk about is thunderstorms. Boulder and the Boulder area gets a lot of thunderstorms. We get about 45 a year or so. It varies from year to year. So there's a nice picture at night over the Flatirons. The picture on the right I took just looking east. So you can see the thunderstorm is very puffy. It goes up pretty high. It's a little wider at the top usually, and it's dark down bottom where it's raining and where it shades the ground. Okay, the thunderstorms are very powerful. Just an ordinary thunderstorm has the amount of energy in an atomic bomb, if you ever heard of one of those. Fortunately, most of that energy doesn't do anything to people. Thunderstorm has so like I said, it's wider at the top. It has something called an anvil, and that's where it's very cold up top. There's a lot of ice, and down bottom, it's usually just rain, and the air in a thunderstorm goes up and down. So the up brings the air up and forms the cloud, and the down when you have the rain bringing basically the air down. When you have the ice up top and the rain going down, that creates basically a charge difference, kind of like when you touch a blanket in the winter, you see you see the spark. So you get that in the atmosphere from a thunderstorm, and so that creates the lightning, which we will see next. Oh, sorry, and one more. There's also, so that was a normal thunderstorm. You can also get something called a supercell thunderstorm. Those are just really big, really smooth and beautiful. They tend to, the whole thing tends to rotate. So it goes around like this. So if you were under it, you could see the air rotating above you. And those are the ones that tend to have the tornadoes in them. We don't see very many by Boulder, but as you go further east towards past Denver and past I-25, you can see more of these. And they can be very beautiful. You can see this one. It's very smooth and very nice looking. Okay, so back to lightning. So thunderstorms have lightning. There's all kinds of lightning. Here's a basic picture. Oh, sorry. Basic picture here. So you have basically a single bolt. They can go from cloud to ground or from ground to cloud, like this one. Or they can go, and like this one, from cloud to cloud. So those don't, sometimes when you have weaker storms, you get more of that. And you can also get more than one bolt, or this one could be more than one thunderstorm. It's a little hard to say. Some of the bolts can go pretty far. I've heard of bolts going 5 miles, so that's pretty uncommon. You do have to be very careful. The lightning is probably the most dangerous thing about thunderstorms. So you want to get inside if possible. You don't want to be standing outside, and you certainly don't want to be standing outside near a tree or other high item, because those tend to be where either attract lightning or they start and go up into the air. Lightning goes up from those things. Okay. Hail comes often from thunderstorms, not all of it. Hail are round balls of ice. So here's some hail here. This is fairly big. Usually they're more like marble size or pea size, but sometimes they're quite big. So these are maybe golf ball or baseball size. So you get hail and thunderstorms. It rains. It was very cold up top. The air goes down. But because you have all this motion in a cloud, both up and down, some of that frozen rain that freezes goes back up, and it gets more and more layers. So these hail balls get bigger and bigger, especially in very big storms. So then you can see like this piece of hail was sliced through the middle, and you can see the layers here. So here's the initial ball, and then there's a layer here and here and here. And to get them really big, you have to have a very big storm, because obviously the hail gets heavier as it gets bigger. And so something sort of has to hold it up and bring it back up so we can get another layer of ice. So those are the biggest storms. Okay, so for softball size hail, like I showed, in order to keep it in the air, you'd have to have 100-mile-an-hour wind going up and down, which is very big. The largest hailstone recorded was 8 inches and across, or 2 pounds in South Dakota. And obviously that would be very bad if it landed on your head. And it's certainly bad for crops and that kind of thing. You can get a lot of hail. Sometimes you get so much hail, you have to get a snowplow to get it off the roads. So in the bottom picture is a family in Netherlands trying to clear their car out from a big hailstorm they had back in 2010. Blizzards and snow. Boulder gets a lot of snow in the winter. We get a few blizzards, not too many. Blizzards are just very, very strong snowstorms. They have a lot of wind. You can't see very far with them, and they last a certain period of time. You tend to get them more as you go towards the east, towards the plains, but we do get a lot of snow. Like I said, we get 90 inches or so a year. Some of the records we have for snow, the latest the snow started was November 15th. The earliest in a year it started September 12th. So a lot of times you even have vegetables in the ground at that point. The latest snow in the winter we've had is June. So sometimes winter goes all the way till June, which isn't always very fun, but it's kind of interesting. The most we've had in a storm was 30 inches back in 1997. The least in a year was, let's see, 40 inches. Then that obviously impacts the ski industry, that kind of thing. And the most we had is 152 inches. And snow can be bad. It can close roads and that kind of thing, cause accidents. But Boulder, Colorado loves its snow. It loves to ski. It loves to sled. It loves to do all these outdoor activities. So it's kind of good and bad. Snow can cause avalanches if you have too much. Colorado has a lot of avalanches, probably has most in the country. They're very dangerous, so you do have to watch out for them. They can knock over trees or whole forests sometimes. So when you're out in the winter, you want to be aware of where you are and what's above you. There are people in Colorado that try to forecast avalanches so that they're less dangerous. So they look at the temperature and the wind and how much snow, and they try to say what are your chances of getting an avalanche. So that's very helpful for everyone. Floods. Colorado gets both large-scale floods like this one. This was this big flood we had back in September 2013, all up and down the Front Range. Boulder had 18 inches of rain in 6 days, which basically matches what it gets in a whole year normally. So it's quite a lot of rain. And all that rain comes down and it fills up the river valleys and the plains, and it goes over houses and stuff like that. Eventually it goes out to sea, but it can take a while. So locally, this is Boulder High School during that same flood that somebody took a picture, and you can see it just covers everything. And the schools were closed for a few days, as were other things. Roads were damaged during that flood, so floods can do that. They can damage houses and roads and fields, and they can also hurt people. So you do have to be very careful if there's a flood around. Like, don't drive a car into water that you can't see and that kind of thing. Floods can also be a little bit of fun. There's my kids rafting down our street during the flood. This is before it got really bad, but they were having a lot of fun, as were some of the other kids. So I guess it's not all bad. You can have something called flash floods. So if you have rain, not as much rain, but if you have it in a very small area, especially a canyon, there's nowhere for the water to go. So the water will usually just run off somewhere. And in a canyon, there's not a lot of room. So it tends to fill up the canyon, and it tends to go through very fast. So here's some picture of, I don't know where this is, in the west of a flash flood. It's very muddy because a lot of water picked up the mud, and then it keeps flowing. They tend to start quickly and end quickly. On the right side is a flood that was in near Fort Collins, so north of here in a canyon. And it was a very, very bad flood. This thunderstorm that just was over the mountains, and it kept raining. And so we learned a lot about floods from that storm. And unfortunately, it was very damaging. But like I said, we learned a lot. And when you see the signs that say climb out of the canyon if it's flooding, that's kind of where those signs start at after that flood. So do watch out when you're driving with your parents for that kind of thing. Droughts are opposite of a flood. It's too dry, not enough rain, sometimes a lot of heat that evaporates all the water that's on the surface. Here's a picture of Barker Reservoir in Netherlands, and you can sort of see the ring around the bathtub look of it. And so, it must have been very hot and dry that year. And so you just hope that you don't have that for too many years in a row, because obviously we need water for drinking and water for our crops. One of the things that drought can do though is make it more likely of wildfires. So we have wildfires in the foothills, mostly around the area. The top picture is the 4 Mile Canyon fire for September 2010. You can see Boulder down here, and there's the fire at night. It was a pretty big fire. If you look there now, you can see all the burnt trees. They're still there, and the area is recovering, but it does take a while. The bottom picture, you can see smoke from the same fire. And smoke from a fire is bad if you breathe it, so you don't want to do that. But there's sometimes upsides to things. Smoke can make for very pretty sunsets. Okay, the observations that I talked about are taken on the where we work at the NOAA NIST site. There's a structure like this. It's a big wooden structure. It has doors in front. So the thermometers are inside. They're min-max thermometers, which means it records the maximum temperature over the 24 hours before it's measured and the minimum temperature. And so the observer gets those values. They also measure the amount of rain that falls. There's a special gauge that I don't show here for that. And if they have to, they melt the snow to see how much rain that was equivalent to. Because if you have really cold weather, snow can be really fluffy. If you have really warm weather, snow can be very, very dense. So you need to melt it to see how much actual precipitation water that you get from the snow. Snow is measured on a whiteboard on the right. So the snow falls there, and they have a ruler, they're measurers, and they see how much it snowed. And sometimes they measure it more than once a day because it tends to compress. It tends to get compacted down. So you want to measure, you want to catch all of the snow that falls. So that anyway, so the site now has been there for 30 years. In fact, it hasn't moved in 30 years, and 2 people doing it have been measuring all that time. There was an article in the paper about it. You might be able to find. You can take observations too yourself. On the left is a rain gauge, and you could do it yourself, or you could be part of a larger group of people in the city that measures the rainfall, so people can see what the rainfall, how it falls in different parts of the city. So it's very helpful to weather people. You can have a thermometer and take the temperature outside. You might be able to get a min-max thermometer. That can be public if you want, or you can just keep track of it yourself in a notebook or something like that. You can measure the wind. So this is an anemometer. So it measures the wind speed. These little cups spin around, and they tell you how fast the wind is blowing. And then there's a directional arrow here that tells you where the wind's coming from. So all these things you can have at home. And another simple thing you can have is either with a camera or a smartphone, or you can borrow your parents' smartphone if they let you. You can take pictures of weather things that you see. For example, clouds or rainbows or thunderstorms. That can be really nice to do, and you can put them in a notebook or something, a folder. And that's a good way of keeping track of the weather. Okay, so finally the end. You can get some of the data, if you're into that, for Boulder, the measured data at this website below. And there's also information in that webpage about the windstorms, thunderstorms, severe weather, what the normal weather is like, and how you can find forecasts or radar pictures. Just a whole bunch of weather-related items for the area can be found there. Okay, thank you all. I hope you found it interesting. If you have any questions, please ask them. I was going to look at the fire tornadoes. I actually don't know too much about them. When you have a fire, you have a lot of heat and a lot of local sort of wind blowing from the heat. And I assume that's all that air moving around, you can get spinning, and then when you have a fire, fires go up. So I assume that makes the spinning narrower and narrower, just like a regular tornado. And yeah, they can be pretty intense. I've seen very big ones in pictures. Usually they're small, they're a foot wide or so. But I have seen with very large fires, you get a lot of heat, a lot of energy, and you can get very big tornadoes, fire tornadoes from those. Okay, does anybody else have any questions?
Okay, I see we have a question. Oh no, it's actually just a comment from Anna and Masha. They said, thank you very much.
Okay.
And Juliana says, thank you very much. Does anybody else have a question for Kathy about weather?
If you have any questions later, you can get your parents to email me, and I'll try to answer them.
All right. Well, thanks everybody for coming to Funtastic Science, and thank you, Kathy, for giving us a presentation about weather.
All right. Well, thank you everybody for listening.
All right.